Welcome to Bluetooth Device Companion Apps at Build 2016, also known as Legos for Grown-ups. My name is Kiran, and I'm a program manager on the Windows Bluetooth team. And I think that we can rid the world of instruction manuals through the use of beautiful apps. This session is all about device companion apps. By the end of it, you will know how to query for nearby devices, connect to it over Bluetooth and initialize it at first setup, and finally be able to communicate with it over Bluetooth Low Energy. But first things first, what is a Bluetooth device companion app? Companion apps provide utility throughout the course of a device's product lifecycle. Now, Fitbit does a great job of doing that. When you first buy a Fitbit and take it out of the packaging, the Fitbit app configures it for first use. During the course of the device lifetime, the Fitbit app also syncs fitness data between the device and their cloud service. Now, you might say that this is a fairly obvious functionality for a fitness tracker, but it is totally applicable to other device classes as well. Take headphones, for example. You could provide interesting troubleshooting guidance or perhaps battery indication. And for fitness devices like LE heart rate monitors or sensor or pedometer devices, the experience can be made far more streamlined using our in-app pairing APIs. Finally, Fitbit does a great job of promoting an ecosystem of devices within the app. If your users trust the excellent app experience that you provide, who do you think they're going to buy their next device from? Having a universal app on millions of PCs, phones, and tablets can go a long way to marketing your next generation of devices. So let's transition from what a device companion app is and see why you would build one. To me, you can distill that into two main reasons. The first is to navigate tricky out-of-the-box experiences. Now, we know that Bluetooth pairing is not as easy as we on the Bluetooth team think it is. In fact, my parents think that putting me through college was completely worth it just so I can help them set up their Bluetooth devices. Let's fix that together and create a streamlined and customized pairing experience for our users, really ensuring that premium feel for a device that they buy. The second reason I think that is crucial is to be able to market an ecosystem of devices for the user. Like I said before, gaining trust through a good app experience and having that on millions of devices is excellent for promoting future products. So that was my pitch for why you would build one of these apps. But I know your next question, and it's how do I do it? And you do that with 3 simple steps. And this is only the Bluetooth portion, of course. There's a bunch of UX work. But the 3 Bluetooth steps, we will discuss them in this session. The first step is to query for nearby Bluetooth devices. And you do that by using the device watcher pattern. The device watcher can be used for any device class, but since it's specific for Bluetooth in this session, you have to first configure the watcher with a Bluetooth device filter. Once you do, and you call watcher.start, that is letting the system know to look for nearby devices around you. Once we know to do that, we will have events firing for 3 specific events, right? Added, updated, and enumeration completed. The key here is you must implement the updated event. Otherwise, there's a 30-second blocking call to the added event, to the first added event. But if you implement all 3 of these, you will be able to get a dynamic list of all the devices around you. specific to your filter, if you decide to use a filter, you will get a collection of devices that satisfy those filter conditions. And finally, when the device that you're looking for moves out of range, the removed event is fired. And so you'd want to implement that event handler in order to keep your collection current. All right, so now that you have a good view of all the nearby devices, the next step is to pick the device that is yours, that you as the app developer want to target, and then ensure that it's available and initialize it. And we're going to use a common pattern for this as well. In this case, I've assumed that a user is choosing the device, but you can, of course, already know what device you need to pair to based on specific device characteristics. So if you already know what type of device you want to pair with, you can hide that functionality from the user. In the demo that we're going to see, I will present a list of devices and then have the user click on it. So once they do click on that device, we will initiate a pairing sequence. Now, the result actually happens very quickly because the initial pairing process does occur in a few milliseconds. However, it takes time for Windows to query and cache all the services and characteristics. So in order to get an event fired for exactly when that device is available for you to use, you use a second watcher. So the first watcher was for nearby devices. This second watcher decides when the device is ready to be used. So we use a service watcher on a specific service. In this case, we sort of, since the demo is all about Legos, we're going to put a service watcher on a specific Lego service. But in your case, if it's a heart rate monitor or a pedometer sensor, you would use it on that specific service. When the added event fires, that means your device is ready. So with those two conditions, right, your pairing was successful and the service watcher, the added event is fired, that's when you know that your device is ready so you can access the services. Once you have a handle to the service, you can proceed to communicate with it over GATT protocol, as you would with, which is a previous pattern that has been present in Windows since 8.1, and your device is connected and ready to be used. And like I said before, once it's initialized, the final step is to simply access the services and characteristics and sync data when required. So let's go into Visual Studio and see how all of this plays out. We are now in Visual Studio, and we're going to see how a device companion app, at least the Bluetooth portion, needs to be coded up. The first key step is to create the watcher. As we said before, you need to supply the watcher with a particular filter. In this case, I'm actually using a protocol ID, a protocol GUID, that returns all Bluetooth devices, both paired and unpaired. But we have more friendly device selectors that are specific for paired devices or unpaired devices. The next step is to implement the event handlers for all of the device watcher events. I've only shown the implementation for added in this screen, but I've implemented updated and enumeration completed as well. When we get a new device that the device watcher returns to us, we add it to an observable collection that is data bound to a XAML list. So there's lots of great sessions on data binding, but for now, just think of it, if we add a device to our list, it's going to be reflected in the UI. And because we're making a UI change in an event that might not be running on a UI thread, that is why we are specifying the that we are using the dispatcher to run it in a UI context. All right, so now we've implemented the device watcher. The next step is just to call start. And this tells the system to look for the devices that specify those particular filter parameters. So now we're looking for all the Lego devices. So the filter specifies all Bluetooth devices, and I'm expecting the user to pick the Lego device out of that. When the user picks a specific device, and in this case we're going to pick the Lego device, the next step is to initiate pairing with that device. Now it's an async call, so we wait for it to return. But note that as soon as you get a result equals success, it doesn't mean that the device is ready. You still need a service watcher. Because we know exactly what type of device we want to interact with, we know that we're trying to look for a service on the device that has been tapped. So we save off the Bluetooth address, and we construct a device selector that basically looks for the Lego service, so the IO service UUID you see there, as well as the specific Bluetooth address that the user has tapped on. So when a device satisfies those two parameters, right, that its service is ready and it has a specific Bluetooth address, our device watcher's added event gets fired. When the added event gets fired, that is when we know that the device is ready to be used. And that's where we get the service. And we use a similar pattern that has been around in Windows for a while, and that is getting the device from ID async, and then getting a handle to the characteristic. And once you have the characteristic, then you can read and write from it, depending on what the characteristic supports. But this particular one supports writing to. So when the user presses the forward button, we can write to that particular characteristic. I haven't shown the implementations for stop or backward, but what's going to happen is you press the forward button, and then we write a value that corresponds to the motor speed to the Lego device. So let's see how this works. I'm going to deploy it to the phone, and then we can connect to the Lego device and then interact with it. So this is a companion app for the WeDo educational kit. So I'm using the Project My Screen app. So I'm using the Project My Screen app, but I'm going to use a real physical phone. And this is the companion app. The first thing you have to do is start the watcher. So we're looking at all the devices around us. Clearly someone has a Microsoft Band in the studio. And when I press the button on the Lego, it starts advertising. So I will find the Lego device and tap on it. Then you use the in-app pairing APIs to pair the selected device. And that prompts a consent dialog. When the user allows it, that's when the pairing succeeds, and the second service watcher is started. Finally, you'll see the buttons light up when the second watcher fires. So there you go. Forward, stop, and backward are enabled, so we can interact with the Lego now. So this is my friend Dave, and he's in another video. But let's see if we can make him move backwards and forwards. All right, Dave, come forward. All right, now stop. And I'm pressing on these buttons here. So when I press the stop button, we're writing a specific motor command to him. And then he's going to go backwards. All right. So that is the companion app for the for the Lego WeDo educational kit. And that was our demo for Bluetooth device companion apps. As you saw today in this session, you can create companion apps for a whole range of devices. And with Windows 10 and the universal APIs for in-app pairing and Bluetooth Low Energy, as well as the host of other Bluetooth APIs that you have at your disposal, you can create really great user experiences for people using your devices. To learn more about this particular demo and to get all the source code as well, be sure to visit our landing page at aka.ms/btdevdocs. We have a lot of API samples as well as reference documentation to all of the other Bluetooth areas. And be sure to visit all the other Channel 9 sessions, all the other build sessions on Channel 9, and continue your education for this and other technology areas at the Microsoft Virtual Academy. Thank you.